Hi everyone. In this video lecture, we are going to learn about comparators. On completion of this topic, the learners can able to understand the concept of comparing two bits binary numbers. So comparator is a circuit which is used to compare the magnitude of two binary numbers. So for the purpose of establishing the outputs, three outputs will be considered. One output is called as greater than concept, another output is called as less than, and the last output is called as equal to concept. So three output concepts are greater than, less than and equal to, and after comparing we can get any one of these three outputs. So comparator makes use of a cascade connection of ideal subnetworks, similar to the case of the parallel adder. So same as parallel adder, comparator is also used to create a cascade connection of ideal subnetworks. So we can consider two binary numbers. Let the binary numbers be n bit. For example, if it is 2 bit means A and B are the two binary numbers, means A0 and B0, and for B it is B0 and B1, A0 and A1. 4 bit means A0, A1, A2, A3. For B, 4 bit is B0, B1, B2, B3. Assume, let us consider AI, BI are entering the subnetwork, that the binary numbers are analyzed from right to left always. Subnetwork is called as 1 bit comparator. So always 1 bit comparator, we can tell that is a subnetwork. So we can add, we can compare the two numbers using comparator. This comparator, here let us consider three conditions of describing the relatives. One is magnitudes A I minus 1, A1, A up to A0. Simply we can tell A0, A1, etc. up to A I minus 1. For B input, B0, B1, etc. up to B I minus 1. For 4 bit comparator means B0, B1, B2, B3. And for 3 bit comparator means A0, A1, etc. up to A2. And another G I equal to 1 denotes that represents greater than. G means greater, E means equal, L means lesser. Gi equal to 1 means that represents A is greater than B. Ei equal to 1 means A is equal to B, and Li equal to 1 means A is less than B. So these are the concepts behind comparison. So here we can use one comparison rule. So this rule says that there is 1 bit comparator as a 5 input and 3 output network. See, the rules here are Ai equal to 0, Bi equal to 1, then L equal to 1. Similarly, Ai equal to 1 and Bi equal to, that is A equal to 0, B equal to 1 means here what is happening? B is automatically high. B automatically high means A is lesser. So lesser is greater, that is Li equal to 1. A is 1, B is equal to 0 means which is greater? A is greater. That represents G equal to 1. Always we are focusing with A input only. Then A equal to 1 means here Li is equal to 1 and Li minus 1 equal to 1. So we can tell this is Ei. If Ai equal to Bi and Gi minus 1 equal to 1, then Gi equal to 1. Similarly, for A equal to Bi, Ei minus 1 equal to 1, then A equal to 1. We can construct the truth table of this comparator like this. So here these are the ways to write the rules of a for a comparator. For any number of bits, these rules can be applicable. So this comparator is used to compare two input numbers, and based upon this comparison the output is considered as greater than, equal to and less than. So we can write the minimal sum of Boolean expressions gi plus 1. Gi plus 1 that is for greater than, ei plus 1 that is for equal, and li plus 1 that is for lesser. By using the two tables we can write like this. So ai bi bar plus ai gi plus bi bar into gi. Ei plus 1 is equal to ai bar bi bar ei plus ai bi and ei multiplied with ei, and li plus 1 equal to ai bar bi plus bi li plus ai li bar. And this is the comparator circuits, three outputs for g greater and e equal and l lesser. So for greater, lesser and equal, according to the received Boolean expressions, we have constructed the output circuit. So here A and B are the inputs. So using NOT gate we can inverting the outputs. Using the NOT gate circuit, A input is inverted as A bar and B input is inverted as BI bar for the corresponding greater, lesser and equal concept. So comparator A greater than B, A equal to B and A less than B, and inputs are A n minus 1, B n minus 1 is the last combination. So A naught, B naught, A1, B1, A2, B2 etc. up to A n minus 1, B n minus 1 are the inputs. And for A naught, B naught it is G naught, E naught, L naught. For G1, E1, L1 are for first bit comparator, and for second it will be G2, E2, L2. So this is a 1 bit comparator which is used to compare 1 bit. So this is the IC used for comparator. Generally comparator is a circuit which is used to compare the binary numbers given. After comparing the given binary numbers, the output received are greater than, equal to and less than, or the combination of outputs we are received.